Hello, this is a quick introduction to the lab today. So I just want to talk about a few things real fast for you. Should go relatively quick, I hope. We are going to just do a mass and volume lab where you are going to take 5 different objects, small cube, big cube, weird cylinder, and sphere. And you are going to measure, I think there's one more actually. I think there's a smaller. I said 5, I think there's actually 6. You're going to measure the mass and volume of every single object. Please, we'll have them up front. Please bring them back up when you're done, sort of thing. So just a quick couple of things. For mass, standard stuff. Oh my goodness, that's terrible. We're going to measure in grams, triple beam balance. You guys have seen a triple beam balance before. This is analog. In case you've never heard this before, best piece of advice with the triple beam balance, real quick, just to make your life as quick as possible, is always start with the biggest amount, move it until it drops, and then slide it back one. Make sure it's sitting in those notches. That way, it basically tells you if you go to 200 and it falls, and you go back to 100, you know the answer is between 100 and 200. And you're zooming in and not just entirely guessing. So yeah, triple beam balance. Then volume is the one I really wanted to talk about with you. That will be measured in, we're doing solids, so technically it's centimeters cubed. Although, quick piece of advice, centimeters cubed, or 1 centimeter cubed is equal to 1 milliliter. So you will actually use milliliters at one point on this. But you just want to, basically the difference is usually if it's a solid, you talk about it in terms of centimeters cubed. If it's a liquid, you talk about it in milliliters. So, real quick for volume, there are, like I said, I think there's 6 objects actually. 5 out of the 6 can just be calculated with your basic volume equations, which is a general reminder for a sphere, that's going to be 4/3 pi r cubed. For a cylinder, that's of course going to be pi r squared times height. And for a rectangular prism, that's just going to, of course, be length times width times height. Now, I said cube actually on this, which you could make the argument is just length cubed, of course. But as with any sort of measurement, I think it is a cube, but with any sort of measurement, it's important to actually measure what is length, what is width, what is height to, in fact, confirm. We don't know for a fact, and assumptions can be a dangerous situation to get into. Okay, there is an irregular cylinder, meaning it does not fit these shapes super cleanly. So for that, of course, just the worst graduated cylinder ever. We're going to use a graduated cylinder with all those lines and all that. Okay, just a reminder with that, of course, go from the meniscus. Fill some water, put some water in there from the back, drop the object in, make sure as much as possible not to spill, because if water comes out, then you're changing the volume. And measure what the meniscus is afterwards, and obviously the difference in that is going to be your volume. Now, you might say, why not do that for all the objects? Well, A, I don't think all the objects fit in there, and B, in a lot of cases, this is going to be a little bit more accurate. We'll talk about that more next week. This whole lab is a setup for talking about kind of just lab reports in general, and kind of everything goes into it and what we're attempting to accomplish in there. But again, you're going to measure mass, you're going to measure volume, and when you're all done with this right now, you are going to graph mass versus volume, which is a general reminder is y versus x, or dependent versus independent. When you have the whole conversation of independent and dependent variables, this is not exactly what we typically talk about. Usually with independent variables, that's the one you're changing, and mass is the one that you measure as it changes. In this particular case, they both kind of change together. There's not really, so there's a reason why I went y versus x. Technically, x versus y should be fine too. A couple quick things on volume. When you measure distances, measure to the 10th. Make sure you're actually, either you can use a meter stick, which we have in the back. Probably most of these you're just going to need a ruler, but make sure on those rulers that you're measuring a 10th. Last thing I want to talk about real quick is how we write down measurements in a lab notebook. Okay, so A, you should have a lab notebook. If you don't already, I thought I had one sitting here. No, it's not. Get a graph notebook. I haven't talked about this. Get a graphing notebook. This is where all of your stuff is gonna go into. If you already have a graphing notebook, leave the first 2 pages, front and back, entirely blank. We'll talk about what we're gonna do with those, and then start on page 3. Whenever you put measurements in, a couple things. One, as you make individual measurements, what you want to do is, like, let's say I'm measuring a cylinder. Like, let's say I was measuring the cylinder of this coffee cup. So I do have a meter stick here. So if I want radius, just go ahead and measure diameter. It's way easier to see what it actually is accurately, and of course just divide by 2. In this case, that is 8 centimeters. Now, as I write those measurements down, what I want to do is I want to write down what what quantity is equals, and then, oops, I almost put 4 centimeters. Okay, I want to see this for all of your measurements. I don't want just random numbers all over the place. Okay, so obviously r is equal to 4 centimeters. Okay, and then you make your other measurements. So height in this case would be 9.4. So I'm going to write down height is 9.4. Okay, this is computer error, not my fault. 4 centimeters. Okay. Then, of course, when you're done with this, I actually want to see your work. Now, when you do your work, don't forget that it's not just for you. It's to show somebody else what exactly you're doing. That's why I'm going through these extra steps. So when you show your work, I want you to show the equation. So you write down what the equation is. You show me what equation you're using. And then underneath or to the side, something like that, you show those numbers plugged in. Oh my goodness. I don't believe this is entirely my handwriting small. Squared times the height of 9.4 centimeters. So notice I wrote it in pretty much the exact same order. Pi, radius squared, and notice I keep the units in every single measurement as well. This is the expectation that you will be performing all year. There are a bunch of steps that I'm usually fine with you skipping when it comes to problems. This is not one of them. Now, I'm not going to finish this without actually doing the calculation. So, calculator. Thank you. No, calculator. Web results. I don't need... Okay, mistakes were made. All right, here we go. If there's a pi button, you can use it. It's going to give you a bunch of decimals. All of those decimals are unnecessary because we are performing actually to the 10th place. So times 4 squared times 9.4. Now, you might say, okay, how many decimals am I going to use here? Well, technically, if we use sig figs, we've actually, this is an infinite number of sig figs, because we know it. These both have 2. So since we're doing a multiplication, we should only go to 2, which puts you at 470. I'm fine if you just want to go to 10th. Like I said, I'm not going to worry too much. 472 point, what was that, 9? What? 5 centimeters cubed. Okay, so when you do these calculations, like I said, put your numbers, label what quantities are there, put your equation, punch that in, give me the final answer. We'll talk more about these details later. Then, once you have those calculations done, I expect a very, very nice table. Take your time. Don't spend all the time in the world, especially for some of you, but like have mass and label it, hey, that's in grams, and volume, and write it a lot nicer than I can on this computer. And then put all of them, put what it is, say like, okay, I've got like cylinder here, and then whatever the mass is, and my 472.3, which is for my coffee cup, not for the objects you're using. But okay, so there's the lab. So you're going to make the measurements of mass and volume. You can do the calculations like I just said. When you are done, you are going to graph these, and I would like all of that done, the chart and the graph and all of those calculations done for tomorrow, because we are going to try to use that tomorrow. All right, off you go.